Everyone, Nathan from Switch on Education. Quick video. I'm getting a lot of feedback from parents around that year 7 and 8 mark. A lot of students doing equations at the moment with their school online. So a quick video explainer here to help parents and students out with these ones. So going back to the very basics of equations, what we've got here is we've got 3n plus 2 equals 14, and what a lot of students struggle with is what this actually means and what we're doing with it here. What this is it's a number sentence, so it's saying 3 times some number, we add 2 to it, and the result's 14. What value is that number taking on? And look, being a pretty basic one, it is one that maybe we can get, guessing and checking. If we guess that the answer is 2, so we can check, 3 times 2 plus 2, well, that's 6 plus 2 is 8, so that's a bit low. So I might choose, the next one is 4, so I'm going to check 3 times 4 plus 2, that equals 14, so I'm right. And look, guess and check is a perfectly acceptable method of solving these, but what we also want to be able to do is have a method that's going to work when the answer is a nice basic answer, like n equals 4, or it's going to work just as simply when it's n equals 3.742. Obviously, if we had an answer like that, it would require a lot of guessing and checking to get down to that answer. So what we want to do is have a method that's going to work just as simply for both. So one method that I sort of always try and use, because I think it's quite nice, is the idea of scales. The old school set of scales, if you can excuse my really bad drawing. And the equals sign here means that these scales always have to be in balance. So on this side, we've got our 3 n's here in their little boxes. We've got 2 over here, and on this right-hand side, we've got 14. So what we want to do is whatever we do in these equations, we need to keep them in balance. And a big thing we've got to remember is equations is we're essentially undoing things. And it's all about what we call inverse operations. And inverse operations is just the opposites. So obviously a plus is opposite to a minus, and a times is opposite to a divide. So we're using these main facts, and we expand on them. There's some other ones as well, like a square root undoes something to the power of 2, a squared, but that's sort of a little bit further down the track. But we're going to focus on this simple one here. So what we need to look at first is, our first issue is we've got all our n's over here, but we've also got some numbers over here as well. Our first goal is to have all of our n's on one side and all of our numbers on the other side of the scales by themselves. So what we want to do is we actually want to remove these two here. But thinking about that balance thing, if we remove those two, then the scales will go out of balance again, and this side will now be heavier. So to bring that back into balance, we're also going to remove 2 from there. So we've gone in, we've taken away 2 from both of these sides here. So what we've done is we've minus 2 on this side, because it's always on both sides of this equal sign here. So we've taken 2 away from this side, and we've also taken 2 away from this side. And now our scales are back in balance. So again, writing what we've got here, on this side, we're left with just the 3n. We've got our equal sign in the middle, and on this side, 14 minus the 2 is 12. So here we've got 3 groups of n, but I'm only looking for, at the end of this, I just want the value of one lot of these n's. So because I've got 3 lots of them, essentially what I want to do is I want to divide that out by 3. I'm going to split these 3 n's up so that I've only got 1. So what I'm essentially doing is, because the 3 and the n are connected by the times here, and again, this is a simple one, you can see the answer here, but to undo this times by 3, we need to do the opposite, which is the divide. So that's what we're going to do to both sides. We're going to divide by 3 over here, and we're going to divide by 3 over here. What that effectively does is it cancels out the 3 here and just leaves us with that single n. So what we've done is we've divided this side by 3, so we're left with just the single n. If we're dividing over here by 3, we can break this up into our groups of, there's one group of 3, there's my second group of 3, and here's my broken them now into 3 equal groups is what I should be saying. And because I've then breaking them, I'm removing those ones, there we go. And I'm left with n equals 4. But we can see that from this simple thing over here, 12 divided by 3 equals 4. Quickly jump through and do another one without my scales, just doing, so let's say that I had 5 times n minus 6, and that's going to equal 13. Now this one, I purposely have chosen a number that's not going to be as easy to see. Again, if I'm guessing and checking, maybe 5 times 5 is 25 minus 6. 5 times 5 minus 6, that is 19, so that's going to be wrong. If I then go down, all right, well, what about 5 times 4 is 20 minus 6 is 14, so that's not quite right. If I go down again, 5 times 3 minus 6, well, that's 15 minus 6 is 9. So I'm wrong in there. I need it to be 13. So look, I can see that my answer is going to be somewhere in between 3 and 4, but it could be quite time consuming for me to then go and keep guessing in between 3 and 4. So this is definitely one that we need this process over here for. So again, we're looking at this, we've got all of our n's, it's 5 times a number, subtract 6 and we end up with 13. So we're trying to find the value of this number here. So what I'm going to do is I'm going to, again, I need to undo this minus 6 over here. The opposite of a minus is a plus. So I'm going to add the 6 to both sides. Once I've done that, that means that over on this left-hand side, like I said, everything's on either side of this equal sign. Then I've got just the 5 n's left over here. And on this side, I've got 19. And of course, my equal sign has to be there as well. Now remembering that 5n is just 5 groups of n or 5 lots of n. It's 5 times n, it's all the same thing. And to undo a times, the operation I need to do is a divide. Now above I wrote it as a divide sign, but this line in the fraction also means divided by 5. So I'm going to divide 19 by 5 over here. So once we do that, again, the reason we're dividing by 5 is we're cancelling out and we're left with just the single lot of n equals. Now we can, and it's probably even preferable, to leave it as a fraction of 19 over 5. You know, this one happens to be a relatively nice number. We know it's going to be between 3 and 4. So it's going to be 3.8, this one, 19 over 5. So in this case, look, it doesn't really matter. There's no difference between these two numbers. If it was like a recurring decimal or an irrational number, one with like lots of decimal places, then it's definitely preferable to keep it as this improper fraction. And like I said, it's probably better anyway. Yeah, thanks so much for watching. I hope that this has helped you out with your equations homework with your year 7-8 student. And yeah, if you have any questions at all, drop them in the comments below and let us know if you have any questions at Switch on Education. Thanks guys.